David Smith here with one more flipped classroom math video. 3 tips before we start. First, remember that you can slow down or speed up the playback if that helps you follow along. Second, you could turn on the captions and watch my words go by on the bottom of the screen. And lastly, you can pause the video at any time to catch up with your notes or think about the topic. Today's lesson covers least squares regression. Right there. So now we're going to get mathematical on figuring out the equation that creates a best fit line for data on a scatter plot. Now, let's summarize what we've done so far. The line of best fit technique that we did in our last lesson meant that you calculated the mean point, x bar, y bar, for your data. You plotted that mean point, then you sketched the line. This is what I would call kind of a manual method. You do this on the scatter plot, and it's a little wiggly. This part here especially, you're just gonna sketch a line. You could do a pretty good job of that, but it's not gonna be perfect. Different people will get different lines. So today what we're gonna do is we're gonna calculate a least squares regression line. And this is done with technology, most likely your graphing display calculator, but you can do this in Desmos, GeoGebra, and probably a ton of other technological tools for doing that. And this is a good technique because you throw the data from the scatter plot into the calculator, and then the calculator will tell you a line of best fit. And then you take that equation, that gradient intercept equation, and you graph the line based on what your calculator told you about the data. So here is another example comparing rainfall to a rice harvest. And here's your data with the rainfall figures in centimeters, and then the tons of rice harvested, maybe for a particular field or a rice farm. And so what we're going to do now is I'm going to turn you loose on your graphing display calculator to find an equation for the best fit line. And we're looking for this format. This is gradient intercept form. So you're going to use your calculator, and I want you to find the R value along the way. We need to confirm that that's big enough that we have a strong correlation. And then your A, which is your gradient, and then your B, which is your y-intercept, and then go ahead and write that equation out. Now, what I have is I've put links down in the comments, or in the description, I should say, to this video that will talk about how to do that with the TI-84 or with the TI-Nspire. Now, if you use a different tool, you're going to need to Google that. There's probably 10 YouTube videos that will explain to you how to do that with any tool that you can have to find this information. So I want you to pause the video. If you need to review the lesson or the help video for the calculator, do that, and then use this data to find these values and come back. All right, I hope that went well for you. Let's check the results, compare what you got to what I've got here. My R value is 0.918, plenty high enough for a strong correlation, so we're good there. That's a good check. My A, my slope, my gradient is 0.633. My intercept, my B, is 11.3, and here's my equation, y equals 0.633x plus 11.3. Now the IB is going to pose some questions. It's not just enough to come up with this equation. They're going to give you this prompt. Interpret your results. So I want you to think about this equation and these numbers that you found. Pause the video, jot some things down, think real hard about what actually is going on. All right, let's see what you got. So 0.633 is the gradient. There's 2 main components here. We need to figure out what the gradient really means and what the intercept really means. So let's attack the gradient first. 0.633. What that is the change in y over the change in x. This is just the gradient formula. And in our case, the change in y is 0.633, the change in x is 1. This is over 1. Now, this is not a correctly written fraction, but it will serve for our purposes. So x, the bottom part, that's the amount of rain that we get, and y is the amount of rice that comes in response to that rain. So there's one more interpretation that we can make using this information. So pause the video and think about that, jot something down. Let's see how you did. 1 centimeter of rain results in 0.633 tons of rice. That's the gradient. It's the amount of change in rice related to the change in rain. So every centimeter we get of rainfall, we're going to get another 0.633 tons of rice. Now remember, this is an estimate. It's not a perfect correspondence. We don't have perfect correlation, but it's going to allow us to do a pretty good job estimating. Now let's interpret the other component, the y-intercept. I want you to pause the video and think real hard. What is the y-intercept in terms of our scenario? Think real hard and jot something down. Let's see how you did. So that's my b value. That's the y-intercept. That's 11.3. Now, it's a y-intercept. It's where the line crosses the y-axis. So that point is 0, 11.3. Now, there's one more interpretation, perhaps the most important interpretation to make regarding the intercept. So think about that and come back. Here's what you get. If no rain falls, we'll have 11.3 tons of rice. And you can get that right out of here. The x value of that point is the rainfall. Notice how that's a 0. That means 0 centimeters of rainfall. And so our function, our equation based on our scatter plot would predict that if we get no rain, we're still going to get 11.3 tons of rice. Now that you've watched the video, jot down a couple notes so you can ask questions at our next class. Remember that you can also watch the video again just to deepen your understanding. Lastly, if you enjoyed the video, please click like and subscribe.